Okay, AP Stats, this is your lesson for Thursday. Um, what we're going to talk about today is the full and complete way to answer a question about confidence intervals. Um, whenever you are told to construct and interpret a confidence interval, you're going to follow this acronym PANIC. Now, this is based on the rubrics that the AP curriculum has sent out. So when they grade your AP tests, they are looking for these certain things in order to receive full credit. So we came up with this acronym PANIC because it's easy to remember and each letter stands for a different part that's required. So the P in PANIC stands for parameter of interest. So you have to state what you're trying to figure out. So with a confidence interval, what are you trying to estimate? What's the population? What is your p hat? So what is your sample proportion? Basically, you're stating what do I know, my sample proportion, and what am I trying to estimate, the population proportion. And be specific, put your answer in context to the specific problem. So this is kind of like if we were going to write a paragraph, this is your introduction. This is your goal. All right, now in order to proceed, you have to check some conditions. So the first condition that we need is we need to make sure that our data comes from a well-designed randomized experiment or a random sample. So usually it'll say in the problem that they took a SRS or they took a random sample. That's what you're looking for. So you state what you need and then you say we were told it was random. The next condition is for independence. The way that we state it is in all these ones that are highlighted is how you state it. So for independence, the way you state it is we need the individual observations to be independent. The way that we check it is we need to make sure that our population is more than 10 times our sample size. This should look familiar to you. It's just that last chapter in chapter 7, I was just giving you baby steps. So now we're kind of putting it in a more complete, coherent presentation, I guess. So independence, you know how when you're sampling without replacement, like with cards, how the probability changes? If your population is huge, though, that probability every time you take one person out, the probability is going to change by so little that it's pretty negligible. So if you have a large enough population, you don't need to really worry about sampling without replacement. The third condition is normality. You're going to recognize this statement. We need the sampling distribution of, but now it's p hat because the problems we're going to be doing now are all proportion problems. So we need the sampling distribution of p hat to be approximately normal. That's how you state it. How you check it is making sure that n times p hat is greater than or equal to 10 and n times 1 minus p hat is greater than or equal to 10. So hopefully you recognize those things. Again, last chapter we were just doing baby steps. This chapter we're going a little bit farther with it. You'll also notice that there's hats now where last chapter there was not. And that was because last chapter they told us the population proportion. But in this chapter, we don't know it. That's what we're trying to estimate. All we have is a sample proportion that we're trying to estimate the true population proportion. So we're using p hat to estimate the true population proportion, which is p. So anyway, this is what you check. If those work, if all your conditions work, then you can move on to n. So P is stating your parameter of interest. A is your assumptions, your conditions. N is stating the name of your interval. Now we're going to learn about a lot of different intervals for the rest of the semester. This is the first interval you're learning about. So when you name the interval, you have to tell what percent confidence. So typically it'll be like 90 or 95 or 99, and the problem will tell you what percent confidence to use. And then for now, it's a one proportion Z interval. Eventually we will learn about two proportions, and eventually we'll learn about T intervals, not Z intervals. So there's going to be different names. We have to be able to identify our process by name. So for right now, this is all we're doing. It's whatever percent confidence, one proportion, Z interval. Then I in panic is the interval itself. So this is what we did yesterday. And then C is your conclusion, which is also what we did yesterday. That's interpreting your confidence interval. So yesterday you learned the I and the C. Today we're learning PA and N. Okay, so anytime you're asked to create a confidence interval, or anytime you're asked to estimate, we are going to panic, okay? When we create a confidence interval, we're giving a window of, we're pretty sure our answer is between here and here. So we're estimating with a little bit of wiggle room. That's what your margin of error is. It's the wiggle room. All right, so anyway, here's our problem that we're gonna do. We're just gonna do panic on this one problem, and then you will have some homework. Okay, so here's the scenario. A local newspaper in a large city wants to assess support for the construction of a highway bypass around the central business district to reduce downtown traffic. They survey a random sample of 1,152 residents and find that 543 of them support the bypass. Right at this very moment, I know my sample proportion is 543 out of the 1,152 in our sample. So 543 said they support this, and this is how many were in our sample. And when you type that in your calculator, you get 0.471. So that's our p-hat. It might help to write down our sample size. Again, was 1,152. Let's see. That's probably all we need for right now. Then if we continue reading, it says, construct and interpret a 99% confidence interval. To estimate, see what I was talking about when it says estimate? The proportion of residents who support the construction of the bypass. The 99%, that's going to help us with our Z star. So remember from yesterday, whenever we do a 99% confidence interval, the Z star that we need is 2.576. So this is going to come into play when we get to our equation. All right, so that's all the important information, and now we're going to actually write out our panic. So this is like a more professional way to write your answer. And I think what I'm going to do is maybe type this if I can. Okay. So the P part in panic. I am interested in the true what? The true, is it the mean or the proportion? So in this problem, it was a proportion. The true proportion of what? Residents who support the bypass construction. Okay, and then in this part, like if you refer back to here, we need to state what p-hat is. So officially, right now is when I'm going to state what the p-hat is. So we already found it. I'm just going to rewrite it. P-hat was 543 out of 1,152, which was 0.471. Okay, so that's the P. You're just stating what you're out to do. Okay, for A, we need to both state and check. So stating, I'll write in black and then I'll check it in blue. So the first condition is that the data needs to come from a random sample, or it could be a randomized experiment. And then in this particular problem, it said random sample. So then I can just say we are told it did, or it was, or something like that. Okay, next condition. I need the individual observations to be what again? Independent. And the way that we check for that is we ask ourselves, is our population more than 10 times our sample size? Okay, our sample size was 1,152. So if we multiply that by 10, that's 11,520. So we're going to have to make a statement, something like, I will assume there are more than 11,520 what? Be clear. I will assume there are more than 11,520 residents in this large city. Okay. And then the last condition that we need to check is I need the sampling distribution, not sample distribution, sampling. If you just say sample distribution, that sounds like you're talking about one sample. But a sampling distribution, remember, was all possible samples of a certain size from that population. So it's multiple samples. I need the sampling distribution of p hat. I'll add the hat in just a minute. To be approximately normal. Okay, and then the way we check that, here's the p hat. The way we check that is n times our p hat greater than or equal to 10, and is n times 1 minus p hat greater than or equal to 10. So let's check that out. So n was 1,152. P hat again was 0.471. Multiply those together and you get 543, and that is greater than 10, so that checks out. And then do it again, 1,152 times 1 minus 0.471. And when you type that in your calculator, you get 609.408, which is also greater than 10. So all of our conditions hold. So that's the P and the A. Okay, next we need to name what kind of interval we're going to make. So I will construct what percent. What did it say in the problem? Go back and look if you need to. It said 99% confidence, and then it was a 1 proportion z interval. Remember how we use z star in our formula? It's a z interval. Okay, and then now we can actually construct the interval itself. So I'm going to write the formula. So this is the same formula from yesterday. p hat plus or minus z star times the square root of p hat times 1 minus p hat over n. So p hat was 0.471. Z star for our 99% confidence was 2.576 times the square root of 0.471 times 1 minus 0.471 divided by our sample size of 1,152. All right, now remember, I want you to type the stuff in after the plus or minus and get an actual value. So when you type that in, this is what you get. Now, what is that? What is the significance of this number right here? That is the margin of error. Okay, so now what you're going to do is take 0.471 and subtract our margin of error, and that will give us our lower bound of our confidence interval, 0.433, and then do 0.471 plus our margin of error. That will give us our upper bound. Okay, so that's the interval itself. So these are all required steps. Show the formula with the letters, formula with the numbers, something plus or minus something, and then in interval notation like this. Okay, and then lastly, we have our conclusion. So C in panic is for our conclusion. So then this is just like what we did yesterday. I am 99% confident that the interval from 0.433 to 0.509 captures what? The true proportion of who? Residents who support the construction of the bypass. Okay, so if we were writing a paragraph, that's our conclusion. Okay, so P is our introduction. A is what we need to check before we can proceed. N is saying what we're going to do. I is actually doing it. And then C is writing a conclusion. Okay, so your homework is to go back to yesterday's homework and basically finish panic on numbers 33 and 34. So yesterday you did the I and the C. So today, what I want you to go and do is finish the P, the A, and the N. Okay? And then you're going to also do number 30, and that's a full panic problem. Okay? That's your homework, and I will see you on Monday. Stay warm.